Hi, in this video we'll be discussing important information of Martin lighting adjustment and calibration of the zoom, focus, and drive systems. All products have been adjusted and calibrated prior to leaving Martin, but when the parts have been changed, or the fixtures have been in operation for some time, calibration may be required. This training will discuss methods of adjusting and calibrating the motor drive systems that operate the effects. The zoom group motor doesn't actually have an adjustment or a spacer. When referencing the images, take note that you need to make sure that the edge of the drive is flush with the surface of the motor. The zoom focus calibration is slightly different, as it requires the same calibration distances mentioned in the previous video. It is necessary to make a map that can be projected to, as shown in the left image. The measurements need to be written or printed showing the spacing. When performing the calibration, you can focus and zoom within those parameters. Similarly to the zoom group motor, for the focus group motor, you need to make sure the edge of the drive is flush with the surface of the motor. It is important to note, as shown in the bottom left image, the shaft is D-shaped, so ensure the set screw is sitting on the flat spot. Gobo 4 symmetrical leggings is used in the approval of calibration along with getting the light spot sharp in the center of the aerial wheel. In order to do this, put the gobo in the position that you can see it in the middle, then create a sharp focus on the gobo. Look at it visually or using a camera to make sure the focus is nice and tight. The zoom focus group belt is attached all the way through the top projection module, and it is difficult to access, so remove the lens group from the top of the fixture and work your way down through the top. As noted on the slide, it is important to make sure that the teeth on the reverse of the belt are flush with the edge of the belt lock and belt retainer bracket. There are two reasons for this. One is if they are sticking out, they will catch on the zoom or the focus. Two is that it confirms you have the correct hold or tightness on the belt. The belt tightening mechanism on all of the belts within the fixture are self-tensioning, which makes adjusting very easy. On the prism motor, there is a D-shaped shaft, as on many others, so ensure that the set screw is on the flat spot of the shaft and that the distance from the surface of the adapter to the surface of the motor is 16 millimeters. The frost arm is renowned for the flag breaking and is a commonly replaced part. Although the slide mentions the need for Loctite on the set screw, it is better that you do not use Loctite on it because the screw is very difficult to access and even more difficult to remove, especially with Loctite. In many instances, the set screw head rounds off because of the Allen key wearing it down before you've managed to remove it. So when the set screw is replaced, do not use Loctite and tighten until snug, then another quarter turn. Lastly, when replacing or adjusting, be sure there is a 4 mm distance from the bottom side of the frost to the wagon main plate. Since the frost arm is a part that is replaced quite regularly, it is beneficial to understand the process thoroughly. The Advanced Service menu allows advanced calibration and manipulation of the fixture. However, there is the possibility of damaging the fixture if it is done incorrectly. The process for entering this menu can be seen in the slide or found in the manual, but you will be met with a disclaimer asking you to proceed or not. The reason for this is there are settings and calibrations that, if done wrong, will cause the zoom and focus to crash, or the color flags to open outward instead of inward. Once the adjustment for the frost arm is accessed, it is important to mention that the frost arm should absolutely not touch the end stop, but get as close as possible to it. There is a safety mechanism to prevent it from flicking back too far. However, it's not designed to be hit and will cause damage to the frost arm. Adjustment of the tilt motor is something that is likely to be done, since the motors are very durable and overpowered for the function they perform. Unlike other previously mentioned motors, these have two flat spots, and it's necessary for the shaft to align with both set screws, as opposed to just one. There is also a set distance of 5.9 millimeters. Loctite should be added to the set screw threads, since the motors are rarely replaced. The pan motor also has two flat spots on the shaft as well, so it will have most of the same attributes as the tilt motor. The exception is the distance, shown in the slide's images, which is 0.9 millimeters from the surface of the adapter to the surface of the motor, leaving a very small gap. As mentioned in the previous slide, all belts are fitted with self-tensioners. The right image shows the tilt belt tensioner and the pan belt tensioner. To adjust the yoke belt, you essentially unlock the tension nuts. Move the fixture backwards and forwards, tilting the head until you see the belt has freedom of movement, where it's not getting caught, nor is it too tight. Once you've determined there is enough freedom of movement, then the nuts can be retightened. Having self-tensioning belts simplifies the process dramatically. Pan and tilt calibration is done in the menu. The procedure specified on these slides is correct for the Martin Mac Viper, but does not differ for other moving heads. The process for pan and tilt calibration can be seen in the slide or found in the manual. Once reaching these steps in the menu, as the slide notes, it is important that you do not press action. Once action is pressed, the calibration recording starts. So select pan and tilt and stop, then wait. As mentioned briefly at the start of this calibration process, the Mac Viper differs from the moving head. The reason is the Mac Viper series head turns clockwise with the lens away from you, and the Mac Quantum series base turns clockwise with the lens towards you. This process is good practice for service technicians and rental companies, since there is no harm performing the calibration on the pan and tilt, as you are preventing a potential fault in the future. This concludes this service training. Thanks for watching, and we'll see you in the next one.